Hello everyone, this is Professor Robotics here. When I'm not teaching programming at the college, I'm also a PhD student at the University of Toronto. And for this semester, one of the courses that I'm taking, I have to work on a course project that is related to something called a single photon avalanche detector. Single photon avalanche diode, also known as SPAD, is an electronic device specifically designed to operate at the breakdown voltage region of a diode to detect single photon. Now, surprisingly, some LED light emitting diode can actually operate as a SPAD. Now, not every single LED can actually work as a SPAD, as I have found out because I've tried all of them. This little pile that I have around my shop here, and none of them actually work. So I have to go and order some special LED here I got from Newark. Okay, the AND 114, because I saw some video and also posts online that say the AND 113 and 114 can actually work as a SPAD. So I have this order. It just came in today. So let's build a circuit and try out and see if it will work. What I have here now is a very simple circuit setup. I have the LED acting as a SPAD and also two resistors. On this side, we have a low resistor that I put a 100K resistor in there, and also a bias resistor, which is a 1K resistor. Now, I could play around with the resistor value to get a different reading, but let's see if we can actually get some reading first before we play around with the value. Okay, so now that I have the circuit set up, let's actually turn on my oscilloscope that I have, the old oscilloscope, but it still works, and also a DC power supply, and see what is going to happen. So now, on the oscilloscope right now, we're not reading anything, okay, because we're not supposed to. We haven't turned on the actual power yet. Okay. So now what we're going to do is, we are going to slowly turn this, okay, to our bias voltage, which is going to be about 20 volt, and see what happens when I turn it. Okay. Let's see. So now by going to 10-20 volt, it actually won't burn out the LED because we're in the breakdown region of the LED, so nothing is going to catch fire or smoke or anything. So let me just slowly increase this. Slowly increase it, and okay, so now we can see there's some avalanche current action going on in the oscilloscope now. Okay, if I keep going with the voltage, okay, it's going to go crazy. So now let's just go back to something that is nice and clean. So here we go, we are getting some very nice avalanche waveform, and each one of those spikes, okay, is actually a photon that is going to this LED, okay, and is detecting them, single photon. Now that we have our circuit assembled with a MOSFET, a comparator, and also a potentiometer so that we can set the comparison voltage, now we can turn that SPAD signal that we have, those spike, into a digital signal that our Arduino here can read. But right now we're not going to use the Arduino to read the digital voltage yet. We are just going to use it to provide 5 volt to our comparator, okay, so that it can operate, but later we are going to feed this signal here to the Arduino so that it can actually do some counting. Okay, so right now I have channel 2 hooked up as the signal output from the comparator, and signal 1 from before is going to be from the SPAD. Okay, so now we have everything on. Okay, I have channel 1 and channel 2 here. So let's see what is going to happen when I up the voltage here. Okay. See, oh yay, that's perfect. Okay, good. So now that I have increased the voltage, we can see from our oscilloscope that we're getting a lot of photon detection, and it's actually interesting that there's some active quenching going on. Okay, so those line doesn't go all the way to 0, it actually get cut off at that point. So this is very interesting. Okay, we get a nice square wave at the bottom. So if I do this, let me just pause this here. Okay, you can see some nice waveform that we can read in from Arduino, going from 0 volt to 5 volt. Okay, and basically what we did is we turned this into a digital signal that we can count using any microcontroller. So what's next is going to be programming the Arduino so that we can actually read this and count the number of photons that we detect within a certain time period. So now with a tiny bit of programming on the Arduino, as you can see here, what we have here is we have our serial monitor going at as fast as it can go, reliably. We set pin 2, so now we're using pin 2 of the Arduino because we want to use the interrupt. Okay, we don't want to just keep polling. We want to use the interrupt so that whenever we get input, we will increase the counter. Now we could do it another way, which is a bit more efficient, by going directly, instead of going through the Arduino function, we could just go and use the AVR register level function, but right now I think this should be sufficient for our purpose. So we're using interrupt. Once the interrupt is triggered, it will increase the count, and we set an interval of 5,000 microsecond right now, so every 5 millisecond, okay, we're going to output a reading. So basically what it does is when it goes through this interval here, every 5 millisecond it will keep counting, okay, and then it will spit out a number in terms of how many photon do we get every 5 millisecond. Now we could play around with the interval here if we want to. Okay, if we want, we can change it to 1,000 or we can change it to higher depending on what the reading that we're going to get. So now let's give it a try. So let's I'm going to put this onto this side and run it with the serial monitor open. Okay, right here, and now what we have here is the same setup. Okay, but now I have this yellow wire here that is hooked up to the digital pin 2, okay, which is running the interrupt with the Arduino code that we have. Okay, and our oscilloscope here is still running, as the SPAD is still firing it away. Okay, and as we can see, okay, we're getting reading around. Now it's very hard to see the reading because the screen goes very fast, but the reading is around 40. Okay, I'll say around 40. We could slow it down, but I don't think we need to slow it down. Okay, so it's around 40. So let's see what happens if I actually put my hand over and cover it up. Okay, now when my hand is over the SPAD or LED light, okay, you can see in general the number of reading actually decrease from 40 to around, I'll say 20, 10, and we actually go down to a single digit sometime. And you can see here from our oscilloscope the action actually decrease. So if I lift my hand, okay, it's a tiny bit more, and when I use my hand to cover it up, okay, decrease a bit. Okay, now that's not that obvious, I guess. So let's try something else. Okay, we're gonna shine a flashlight, okay, against the SPAD that we have, and we're gonna see how the reading change if I put a flashlight that shines some light right on top of it. Okay, so what I have here is a little construction style kind of light. Okay, if I turn it on, as you can see, it is very, very, very bright. Okay, so I'm going to shine this on top now. Okay, and see what happened. Okay, oh, our SPAD got very, very excited. Okay, there's almost no, I would say there's no downtime. Like it's just straight flat at 5 volt almost in terms of the comparator output. Okay, so it's getting triggered like crazy, but I think that's not a good sign because then we cannot really count. So let's not put the light that close. Okay, yeah, because we have to introduce some dead time in there, and I haven't introduced the dead time yet. But in terms of the reading wise, okay, we're getting quite significant in terms of the change of reading. We're getting 70s, 60s, and sometimes going up to the 80s in terms of reading. And when the light is not shining against it, okay, we went back down to the 30s and 40s. And once the light is on top, okay, we're at the 60s and 70s. Now you might be wondering, why are we doing SPAD here? Like, what is the purpose of this experiment, and why are we doing this? Why are we using an LED, use it as a SPAD, and read it using an Arduino? Now, this concept of using a SPAD to detect photon is something that is very, very new in terms of technology that came up in the past decade or so. Okay? And because we're using a SPAD sensor to detect single photon, okay, it can still sense light at very, very low light intensity condition. Okay, and because of that, when we use this as a camera, okay, we can get a much higher dynamic range comparing to our typical CCD or CMOS camera. And this right here could pretty much be the next camera. So if you're interested, you can actually get your own LED, get your own transistor and a op amp as a comparator, and you never know, you might be the next person that developed the next cool, awesome, crazy camera. So now, stay safe, stay healthy, and I'll see you in the next video.